Hello, welcome to the section on configuring 5 routers in a network. Okay, this is going to be a static routing. We are going to have 5 routers in a connected configuration, closely connected, and each of those routers are going to have 3 interfaces connecting to 3 different networks. We will see how DHCP is configured in each of those networks, as well as the routers are configured to route the packets to the shortest path. Now this is the circuit we are going to study in detail. If you look at the IP addresses starting from this network, this 192.168.10.0, see, always we mention the host ID portion 0 when we are referring a network. If you are referring an IP address, we will always give IP address which is the host ID portion will be non-zero, and it will not be all F's also, right? All ones. So here /24 means that it is a class C network address. So 192.168.10 is the network ID portion, and the lower byte of the IP address is the host ID portion. Now we have 10, 20, 192, so 20, 30, 40 and 50. So these 50. So there are 5 networks which are of class C type, and there are different hosts, and there is one server here that I am showing. Each of these network have each of them has a server there, which is doing a purpose of DHCP, dynamic host configuration protocol. It runs, it allocates IP addresses to all the hosts in the network. Now, as I have given these addresses as 192.168, all of them are class C addresses. Now there are routers, you can see there are 5 routers connected to each other through a interface, okay, single line. But you know that a network is always in the border of multiple networks. So here 3 interfaces are there, then these 3 interfaces are on 3 different networks. Now let us try to understand. Maybe one router I will take it and try to make you clear. This is one interface. I am not going into the details of which interface I am doing it. Anyway, it is seen here, gigabit interfaces 1, and this is 0, and that must be another interface of the router. Okay. Now what are the IP addresses of them? How do I know? This is given as 172.20.0.0/16. 16 means this portion is network ID and this is the host ID portion. Now I need to differentiate. If I am using /16 notation, the subnet should be different on each network. So 170.16 here, 17 here, 18 and 19 and 20. So they are all different. I can keep anything on the host ID portion. It doesn't matter as long as the network ID portion are different. Now let me look at what is this host ID 2 and 1 means. What I mean, these two refer to the interface IP addresses. Always remember, a router interface on a network will have a valid IP address. So if it is on this network and the host ID portion I am showing it as 2, then you can say, you can find out IP address of this particular interface as 172.20.0.2. that is the IP address of that interface. And there is one more interface connect from this router which is also on the same network. That means both of them should have the same network ID portion, and it should have a different host ID portion. Okay, that you remember. So if I am saying 2 here, it should be different because it is on the same network. So I cannot have the same IP address given to 2 different interfaces or hosts in a network. So this address will be 172.20.0.2, sorry, 1, because I am showing this as a host ID. So this is 1. So this is 2, this interface is 172.20.0.2 and this is 172.20.1. So similarly, if I have to show you the different IP addresses, I am giving host ID as 2 here, host ID as 1 there. This is, I am talking about these two interfaces, and the network is this. So you can easily say that 172.19.0.2 is this interface and .1 is this interface. Similarly, these two are different. So remember, I can have either 1 here or 2 here, doesn't matter, or even I can have some other 10, 20 or even 10.20 and 10.10 is allowed, because as long as this network ID portion is same, host ID portion needs to be different, and it can be different in these two bytes portion. Okay, and since I am using only 1 and 2 here, you have to assume that this is a 0. So the third byte is 0 and the lowest byte is 1. So these two are different. Similarly, this network has two interfaces with the host IDs as 1 and 2, and this is again 1 and 2 for this network. So now suppose if I have to change this network to have multiple hosts in it, it's not that I need to connect them directly. I can have multiple hosts in this. How can I do this? I can actually introduce a switch here, and then let this be connected here, let this be connected here, then that will come through. Then I can have any host with a different IP addresses, 172.16.0.1 is taken away by this guy, 2 is taken away by this interface. So I can have 3, 4, 5 up to this is can be 255, this can be 254. Okay, so I can have that many number of hosts in this particular network. Now if I want to expand it, I will connect multiple switches and then connect to each of those switch ports. I can have multiple hosts. So this is how a network is expanded. When you want to connect more hosts in a network, you can do this. But right now we are not using this network for connecting any host. We are just interfacing two routers. Now the question is, how am I going to configure this whole thing? Now first thing is to configure each network. Now I said that each of the servers are going to be a DHCP server. That means dynamic host configuration protocol is running on them. I have to enable this service. I will show you the configuration done on this already using a packet tracer. Then we have to allocate IP address to the interface of this server. That is very important, because the DHCP server comes to know on which network it is based on the IP address you provide to that interface of that server. So I need to give a valid IP address, and I will open up the packet tracer and show you. I have to give a valid IP address in this network so that it knows in which network it is. So 192.168.10. I can give 1. That IP address will be the interface of this server. Now once I give this and then I give the mask subnet mask as this, then it knows that it is a class C network, and it has taken away this IP address. Now it is also connected to a router interface. Now this router interface, remember, it is not on this 172, it is on this network. So I can maybe assign it 168.10.2 suppose if I am giving this as a IP address. Then I have to inform this DHCP server what will be the default gateway, because for this network to go out of this network, the router is the only way out, and the interface of the router is where I will send the packet to, and then this router will take care of sending it to any of the interfaces it is connected to. So then the default gateway will become this one, and DNS server is something which is used by the browser, where it doesn't know the IP address of the website that you are typing in. Then that can be any popular DNS server that you know. 8.8.8.8 is one possible thing which you can give it. Now once you do that on the DHCP server, its own interface IP address, and then you configure the router's interface also, and provide the subnet mask, then the default gateway address, then DHCP knows what are the valid IP addresses I have, which I should not make use of. This .1 I have used here and .2 I have used, which should not be used, to allocate to the host. So So whenever the host comes on, we have to say that you have to take the IP address using DHCP, not statically allocated. Then the DHCP, when the laptops or a desktop powers on, it will send a query to the DHCP server. It will do a broadcast. It doesn't know whether the DHCP server is alive, is there or not. Then if the DHCP server is there, it will respond back that yes, I am alive, I can give you the IP address. Then it will ask for provide me an IP address, then it will acknowledge it with an IP address. So it will keep track of all the IP addresses allocated, so that whenever a new host comes into the network, it will give a new IP address which is unique in that network. So then allocation of IP address to the host is not the job of IT admin, it is done by the DHCP server. So you have to give a range of IP addresses. Okay, even though in a typical class C network .1 to .254 you can provide, but you can tell that I don't want you to use all the IP addresses that I am having. Maybe you give me till 100, okay, .10, 100. Then you can give a range of IP addresses in the DHCP server. Then it will allocate maximum that many number of hosts. Then it will say that there are no IP addresses that can be given to the host. So there is a limit on what you can connect based on how much configuration you have provided, how much of range of IP addresses you have provided, done to the DHCP. So this is a part of DHCP side. Now once I configure the DHCP using the DHCP, I can allocate IP addresses on each of this host. Then your job is to make sure that they are all connected, okay, because they are all like islands now, and routers are the only devices which can route the packet. So I am going to show you how to configure them using the static configuration routing in this video. Okay, now let us just see, in case if you want to bring up the circuit with a router, a specific router that I am choosing. I will be providing the this packet tracer also file, Pkt file. So you will know that it will normally show only 2 interfaces, gigabit interfaces. Now if you want to third one to be available, you need to bring up this physical configuration and then move, with the mouse you can move into this area. Then this particular module will be connected and you will have a third interface appearing. Okay, that's how it will be done. This we are not going to do this in this video, but it will be helpful for you to know how to bring up the third interface in the router. Now configuration guidelines. You have to configure the DHCP servers. I explained. Check each of them is working fine. How do you check? You open the laptop and see whether the IP address is allocated properly, and then ping the machines on the same network each other, and so that you know that that particular hosts are properly configured. And then you have to provide the IP addresses to all the interfaces of the router. You have to open each of the interfaces. You should know which interface is connected on which side of the network, and it is shown. So I will tell you that how to see the labels of all the interfaces, so that you don't get confused in configuring the IP address, because when you configure the IP addresses wrongly, it will not work. It won't give you any error, it won't blow up the router, but it won't work. That's it. So configure the routing table. Sometimes the router, when you are configuring it, it will give you error, but many of the time it will keep quiet and you will not know why things are not working. Configure the routing tables on each router. That also has to be properly done. Make sure that the routing table takes the packets to the target network in the shortest path available. Okay, you are free to do anything, but it is better you try to find the shortest path. Check the interconnection of all the networks. You have to enable the router interfaces, and then how do you see whether the packet is going in a particular direction? You can do a trace route of one particular IP machine available on other network. Then you will know the path in which it is going. So it will be interesting to know how it is going through the network. Okay, now let us get into the meat of this thing. Now this is the configuration which I am going to provide. No config. That means I have not configured the routers in this. So let me keep the picture up by the side so that I know which IP address I need to use. Okay. Let me Okay, now let me show how the DHCP is configured. I'm not going to do that. So you have to enable the DHCP service, okay, which is already running, and server pool. Okay, now configuring it. Okay, I have not done this here. Okay, so let me say that I am going to use DHCP. Now here what you should do, remember that on the DHCP server you should not choose DHCP, because this is going to be providing the IP address to everyone, so it should not have a DHCP enabled. So it should be statically configured. So as I mentioned, there are two things you need to configure. One is the interface, what is the IP address you are going to give, and then the settings wherein you have to say default gateway. Now let us see here. I have not mentioned the IP address, so let me open a configured one to be sure that we don't configure it wrongly. So let me open that. This is one which is configured already, this Pkt. So now let us open this router which is having an interface. The 02 is what is connected to this, okay, the interface with this gigabit in 0,0/02 is connected to the C class C network, and it is given a 10.1. so I have to provide the configuration as a 10.1. so let me explain. I go back to the configured one. I have given that as a default gateway. So this DHCP server default gateway is this interface which is 10.1. Now that means I should not use that 10.1 as a IP address for the interface. So I have provided 10.2 as the IP address. So you have to provide this, and then the subnet mask. Then go to services, you have to enable DHCP, which I have already done, and default gateway I have to configure. DNS server I have configured, and then the range 10.0 to 255.2. Again, I am giving all the range of IP addresses you can provide, but it will know that already one is used up, and its own IP address is 2, which I have shown you. IP address, its own IP address is 2, and default gateway is 1. So it knows that these two addresses are used up. So it will provide the IP addresses other than these two to all the hosts which are connected. So let me open one of the host and look at the IP address which has been allotted. It is 10.4 is allotted. Okay, and if I open the other one, which interface is 10.3. So it is allocating from the lower number from the host ID portion. Okay, and then you have to make sure that DHCP is chosen here. It's not use static. Then the hosts are configured properly. Now this is DHCP server is running, and I have enabled the DHCP service. Services on I have done. It is done. Now let us look at the router. How do I configure the router? Okay. Now first thing is, go to static. I am configuring the routing table. Before that, I have to make sure that all the interfaces are configured with the IP addresses. With this has to be done statically. Okay, there is no DHCP server which is coming and then giving the IP addresses to the interfaces, because you imagine this interface, normally the router interfaces are configured by admin. Okay, it's not, DHCP is not used for configuring the interfaces of the router. So let me look at the interface which is 002 is connected to the class C network. Okay, I have given this IP address. Okay, 192.10.1 and subnet mask I have given. Then 00 is the lower interface. Now lower interface is having 172.20.0 and the host ID is 2. Okay, the lower interface of the router 0, host ID is 2, and then it is on 172.20. So 120.20 host ID is 2. So I have configured the lower interface with this IP address. Now what is this one? This one is on this network. This is 001. and the IP address is 16, 170.16. So if you look at this, I have given 170.16.01. So all the interfaces of the router are configured properly based on this picture. Okay, I've already given this, and then I expect you to be configuring it based on this. Now imagine this router has to be configured also, right? First thing what we should do is go around all the routers and configure all the IP addresses of each interface. So let us open this router, and you can easily find out that I am giving .1 to the default gateway. So it will be this interface, whatever 0/01 is connected there. So that is 20.1, and you can see that 0/0 is connected on this network. So it will be 170.16.0.2, and of course the 001 is connected, like 002 is always connected to the top. Okay, 1 is here and 0 is here, the /0. So /1 is connected to host ID 1, is given host ID 1, and it is on this network, so it should be 172.0.1. so let us just open this. Okay, to be, I will keep it by the side, so that whatever I am explaining we can verify whether it is really configured like that. See, always /0/2 is on the class C side, and the top, that is 20.1. I am giving the lowest ID to the router. Now /0, you can see that label showing up. How do I see the label? I will tell you that. So it is on 16.0.2. so 0/0 should be 16.0.2. then 0.0/0/1 is on 17.1. So 17.1. So this is how all the configuration is done. Now if you want the label to be displayed, go to the options, preferences, and enable this always show port labels. This has to be enabled. Then you will see that all the labels are enabled, so you will know which interface is on this side. If you don't know that, then you will be configuring the interface IP addresses wrongly and nothing will work. Okay, now having taken care of the IP addresses, I will only show how to configure the IP routing table, static IP routing table of one router, which is router 0. This is the router which I am going to open up. Now I want the shortest path, right? Let us see how it is done. You have to go to a static. Okay, now these are the entries. So you have to make this 172. Let me tell you, first entry is 192.168.20.0. I will say 0. I won't say /24 and all there. Now mask is 255.255.255.0, which will say that it is /24. Okay, so this two has to be given, and then via the next hop. Now how do I know which hop I am supposed to go? This is a target IP address I want to go, destination IP address, which is 20.0.0. From this router I want to go to this network. I need to send it to this interface, the far end of the network, not to the interface on this side. Okay, if you are putting it on this interface, it's going to not move out. It has to move on this interface, on this link, to the other side of the router, which is the router. This is the router which is connected to the 20.0. so its IP address is 172.16.0.2. so you have to give exactly the IP address of that particular router. Okay, this is how I have given to make this entry coming up. So I have to give add, then this get added. So to go to this 20.0 network, I will send it to this interface. Now think of one more thing. I want to send it to 30.0. Okay, then I will change this to 30.0. Okay, another thing. Now I have to choose what is the IP address. Now do not give IP address of this interface. Okay, you may be intuitively thinking that I need to give it 172.17.0.2 because that is how this router is. No, you cannot jump. You cannot directly send something from one router to another router without the skipping the router. Okay, you are directly connected to this router and you can only send it to the router. Then this router, which will in turn take the packet and create another Ethernet frame and send it on this link. You cannot directly bypass one router and send it to another network. So it should be, because the reason is you are directly connected only through this router to this router, and you IP packets are not sent directly, right? It is packed on a Ethernet frame and sent. Now Ethernet frame can only be sent on a direct link. You should be on the LAN on which you are connected to. So this is the one network, which is 170.16.0.0 is one network, and this router interface is the only way out. You can reach this guy in the shortest path. Otherwise you can come through this also, but I want to reach through a shortest path, so I will send it to this router only. Same IP address. But you may wonder, my interest is to reach the 30.0. Don't worry, it will come to this router, and this router is going to have a routing table where you will be mentioning that if you want to reach 30.0, send it to this interface, which is 170.17.0.2. Then router will send the packet, create another Ethernet frame, get the MAC address of this interface through ARP, and then send it on the Ethernet. So it will finally be reaching. So shortest path is through this. That's why the next entry for 30.0 also is same interface. Now, having understood this, it is very easy to predict what will be the entry for 50.0. I want to reach this. Now you may wonder that why should I give it for every network? Yes, you need to. Otherwise, the routers are not knowledgeable to know that there are other networks in this picture. Remember, they are all localized. They don't have the global view of the entire network. We are seeing it because it is provided with us the diagram, but the routers are localized and they will only act on what is configured in them. So you need to configure the router to say that, hey, this is the way you have to send it, because there is one network which is configured as 50.0. If you reach this router, that router will be able to help you out. Now, what is the address of this interface address? It is 170.20.0.1. So if you want to reach 50, which is 50.0, you have to send it to 170.20.0.1, because host ID is given here. Once I give it to this router is already on the network, so it will find out the MAC address of the host and then send it there. Okay. Any router, without consulting the routing table, it can send a packet to the interface network which they are connected directly. If they have to hop to another router, then they will be asking the another router and its interface IP address, and it will send it to the router. So directly connected networks can be reached by the router without consulting the routing table. So if you want to ping 170.20.1, you don't need a routing table. You don't have a path here to say that how do I reach 120.0 on this router. But remember, if I need to configure reaching this network, then I need to provide on this router another entry. Okay, here we are only using the 172.20 or 19 as an intermediary, and it is being sent from the router to router. But if I directly want to send a packet to one of this network, I need to have an entry there specific to that particular IP address. Okay, or the network address, right? And it's not even IP address, it's a network address. So for example, on this router 0, I need to have an entry to ping 19.0.1 or 2. Then this network is not known to this router. Then you have to configure it. So I will say that here I will say 170.19.0.0 and 255.255. Okay, let me write it out. Okay, suppose if I want to configure another entry, I will get this and then 0.0, because it's a /16. Then how do I reach the network? I can reach it through this whole interface. 20.0.172. Okay, it is not 160. Sorry, it should be 16. Okay, 0.1. If I do that, then what will happen is, oh sorry, this side I am coming, right? I need to say 20. Okay, let me. Okay, now I think it is clear. If I want to reach this, okay, if I want to reach this network 170.19.0.0, this is the IP subnet mask because this /16, and I need to send it to this interface. Then this router is directly on this network, so it will be able to reach. So I need to send it to 20.0.1. So similarly, if I want to reach 40, shortest path is this and this interface is this. So I will send it to 40 also, I will send it to the same interface. So you can have multiple entries for reaching a router, reaching any network, giving the same IP address of the router interface. It doesn't matter. I can have any number of networks can be reached through one particular interface. So I can have multiple entries here. For every network, I need to say which interface I need to send. So for reaching 20 and 30, I am taking this path, and then 50 and 40, I am reaching this path, because the requirement was to configure the shortest path. So this, once you do that, then you can actually do a desktop command prompt. Then I can say trace RT, okay, trace RT. Now suppose I am on this laptop 3, which is connected to this network. Let me check if I have to 30.0.3, okay, 192.168.30.3, 3 will be there, okay, 1 and 2 are also there, 3 will be one of the hosts. So this is how it is going. Now let us try to understand this particular thing. How is it going? Okay, then we will end this video. Now what am I doing? I am tracing the path from this laptop, which is on 190.168.10.3 to one host on this network 30. Now first it went to 10.1, okay. Now which is 10.1, because this router default gateway is this 10.1, right, which I have configured it. So it has reached that router, and then I know that because of my routing table, I know this will be the next router, it would have gone. So this router, on this interface I sent it, so 170.16.0.2, so it went to this interface, okay, it was sent to this interface, and then next it was sent to this interface 2, and IP address is 17, so 17.0.2. Then it reached my target destination 30.3. So this is how it reached. So you can try out maybe one more thing. Let me tell you 40, how am I going to reach? So let us see that. 40.3. I am going to go to 120.1. First, initially I will go to 16.10.1, then 170.20.0.1, and then this interface is also 19.0.1. Then I will reach the target, which is 40.3. Okay, so this is how this whole configuration works and the trace route works. Okay, I hope this is clear, and see you in the next video. Bye bye.